Hi everyone, welcome back. So today what we need to get started on is we need to fix our different step printing. I mean, I say printing, but really it's drawing colors to the screen, right? Using macro quad. That's kind of messed up when it's multi-threaded. I did some print lines. It showed me that we were not going through every spot that we can. So that's an issue. So we need to like change the loop a little bit. Nelly? One sec, I think I think she got something stuck under the door. No, she was fine. She's just crazy. Okay. Yes, let's start on that, and then we still also need to fix the collisions on the wall. Looks like we're phasing through. Which is not good. So let's kind of see where we are at the moment. Right, if I bump that out, there we go. So you can see like there's lines all over the place. This is, that's not correct, obviously. It's not supposed to be like that. And then, but the big ticket issue right now is if I change this to even 5, right? It doesn't print, it misses printing like the whole thing. So it's printing the actual top, and then it's skipping a ton, and then it's printing the bottom. But if I look here, let's see, does it even tell me? Yeah, I have 7,200 data points, but it's printing 1,400. Or I have 72,000 data points, but it's only printing 1,400. So that's kind of the issue. Instead of looping, I can see that, I just found that just from some printing stuff. So here, we're looping through screen size, which is, I mean, obviously not what I need to be doing. I need to be looping through distances.length. Well, I is less than distance.length. I plus equals 1. Let's just do, I just made a for loop. For I in 0 to distance.length. I think that's correct. Okay, right, so I can't do this. That's not gonna work anymore. But yeah, that's right. Don't need this anymore. Okay. I don't need that because I know now I'm gonna print every pixel in distance. Okay. So, I don't know now what happens. It's running. Still only does that. So I'm doing something wrong here. So where's my like... X, Y. Let's check them out. X and Y. Don't need that there. Oh, what was that? X is just always 0. What's going on with this? Oh, well, that's why. Let's do it right there. X equals X plus step. That looks right to me. Well, I have 3,000 before it loops. That's wrong. Screen size is 600. It shouldn't go over 600. Maybe that's my issue now. Let's see what we're printing at though. Okay, we've seen enough. So X goes up until 595, then increments that by 5. So that's correct. But how is Y getting to 2,870? Did I break 1? It should be doing the same as math, right? So 1 should still work. Yeah, this still works. Shut that down. Okay. Just a note for later. So this is a crazy way to do that. Okay, let's see. Yeah, right. So that's correct. So I'm getting confused. Let me see. This 10's a pretty spectacular break. About 100. That's even worse. Let's try 100. It can't be 3,600 data points, though. Right? I'm doing 100 by 100. There should be only 36. How am I making this? How am I making this? Yeah, I think I'm just overdrawing, or I'm not overdrawing, but I'm making way too many. Do I need to do time screen sizes here? Yeah, so how many am I actually doing? So, say I cook this up by 8, right? If I look at this, it's only 1, 2, 3, 4, 5, 6. It's only 6. Yeah, it should just be a 6 by 6. So stop Y and start Y. Let's check those out again. Oh man. Bringing this loop is not what I need right now. Okay. I think I need to do like this divided by step. That's crazy. That looks absolutely crazy. As F32. Yeah, I mean, that's what it's supposed to look like for 100. But if I bring this down to like 50, that looks right. If I bring this down to 20, looking good. Down to 10. I know it's going to work, but I want to see it, right? Yeah, like this row is kind of messed up. Okay. 5. Two. Looks very similar to 1, which is what we are expecting. And 1, right? All right. So let's figure this out. We have stop y minus start y divided by step. That is rows equals this. So 32. That's still right. Yeah. So screen size times row divided by step. That's actually let's just put screen size on row. Is it U size? Putts. All right. Just bring those back. Because I need to do it as U size. Yeah. Okay. That's pretty wicked math. I wouldn't want to run across that just in the wild. Okay, looks like it's done. So, multi-thread bug done. Let's look at walls now. I can't guarantee anything with this walls thing, but we can at least see maybe where it's going wrong. And this, we do guarantee this is joining the correct order, so you don't have to worry about that. Typo, clean it up on the way. True. I'm not gonna need that anymore. I'm not gonna need that anymore. So let's see, what's kind of the lowest, or I guess highest number that recreates these? 5 recreates a step, or recreates a phase. 10 recreates a phase. Just 20? The higher we get, the easier it will be to look at this data narrative. 20 recreates a phase. Does 50? I doubt 50 does. Hard to tell with 50. 20 definitely does, though. Okay. So right, we're looking at this line right here. Because this should be more filled out. Like, it should be more orange like it's showing the rest of these. So we're doing something wrong. The way we can look at that, the way that I'm going to look at that, is, now that we have our distances, we're going to print them. Printing in distances. Actually, what's the best way that I could do this without it getting too crazy? That's not gonna work. If I take it down here, let's see, is there like a Rust print no new line? I'm sure there is. I just don't know. It might just be print. It's trickier than it would seem at first glance. Just use the print. I'll just use the print. So what I need to do is I need to do print value space distances I. And here I need to print line, just to add a new line there. That works. Let's see if on 20 if it'll take it. Do it up here. And I want to do let's start with this. Start with this. Maybe, and I'll figure it out later if it's easier to look at it one way or another. Okay. Yeah, so I want to do this one time. Okay. Now I have this. And if we look, yeah, there's 900 data points. It's not easy to look at. So what I need to look for is like an anomaly, right? Why do I keep closing this? Okay, so I think the first one that we'll see is 0, 20, 40, 60, 0, 20, 40, 60, 80, 100, 120, 140, 160, 170. So on the 170 there should be a make. Not 170. 180 there should be make. 180 height there should be make. Let's see. Yep, there's make here. And then I'm looking for something that's kind of weird. 420, 180, 420. Okay. Yeah. That's what we're looking at right here. This dot matches up with 420, 180. So at there, we're doing something weird with collisions. There's some weird with wall collisions. So I need to set up a little test. See what's happening. I'll set it up in here. So what do we have? I need a new hole. I only have from file. It's the only way to make this thing. You know what, that's fine. I think I still have it in here anyway. Hole. I don't. Folder. Res. Source res, that should be fine. Test hole, let's copy that. Put it into res. We're good to go. So, I'm gonna make this hole. Mute h. Choose a hole equal. I don't need the whole thing. This hole from file res test hole. Let's check this out. CD into hole cargo test. What about it? Expected string found and stir. Dot to string. Why did it fail? Ball not defined in file. It's right there. Maybe I need to move it back a level. Yep, okay. So now we're built. We have this hole. On 420, 180. So I need to do while h dot ball. That is moving. Ball dot hit 420, 180. While it's moving, do the basic stuff, you know. Move and glide. collide with the walls. And then I need to do assert the distance between less than, it'll be less than 180. Ball did not collide with wall properly. Okay. Check it out. Okay, 0.0. 0.0. H dot ball, H dot ball. Collide, distance equals, I don't pass in. Is that gonna work? Probably not. It'll work. So yeah. So there's the issue, it's creating. So now in a wall, distance to wall. No, that's okay. I need to do it in ball. And collide. So this might be the issues, and we might need to do some fixing here. But here we go. Collide with horizontal wall. Here we have collided with a vertical wall. So it should just be one bounce. Maybe it'll bounce off the vertical also, but it should be like 1 and 1 at most. So what's actually happening? Collided with the horizontal. And then it looks like it didn't do the, it didn't hit the vertical one? See, if I put this at 400, let's see what happens. Yeah, it's fine, right? I can just do and false, I guess. No, it also just only collided with the horizontal. Get these out of here, I don't want these anymore. Not helping. Never even made the slanted wall. Classic. Okay, collided with horizontal wall. If I look back here, right, because it's 0, 30, 60. No, I'm talking about, this is looking right here. Okay. So we need to back it up. It's 100 and 180. Yeah, 196. This should be less than, still should be less than like 180. I was looking at the wrong one. So this is 100, 180. I think it just goes straight through. Whoa, okay. That is super weird. Let's go to play. Let's close this out. All right, this is in here. I need something to tell me where I'm pointing at. Let's pause. Let's print that out. I need to do 100, 180. Mouse position. Okay, so 180 is right here. 100's over here. This is gonna be damn near impossible. Okay. So I can do actually, let's break that back. Go to space. If is key pressed. Key code. Enter, I guess. We'll do enter. Let's do this, and it's 180, 100.0, 180.0. So that should happen when I hit enter. Yeah. Yep. It just like eats it. I think it I need to like push it out. So when this ball hits the wall, it's horizontal. No, it's in the ball. Collided with horizontal wall. Let's make sure we get the vertical wall first. We need to push it out to the right. So x equals w dot pos dot x plus, it's called like half wall thickness. It's half wall thickness. Unknown field. W dot pos. It doesn't matter, it's vertical. Top left. Not accessible. Gotta make it pub. Okay. I'm even farther away. What happens now? It went even farther into the right? Or into it? What does it count? What is a collision? Distance to wall is minus self dot radius plus self dot radius. That looks right. Okay. But that's only if it's velocity's positive now. X is greater than 0. Because if it's hit on the other side, self dot x is less than 0. I need to subtract it all. Minus that. Yep, stuck in wall, push it out. This might not be necessary. We'll see. Let's copy and paste these into this and try to think about it. So velocity is positive. Right, now we're talking y. Y. What's that? X. No, it's y again. Y. Horizontal values, the y's are the same, so it's matter. Plus minus. I think that should be correct. What's going on here? 0, 1, 0. Okay, looks like it actually, the test worked. I'm in a ball. Well, that actually worked. Okay, so that might have done it. That might have done it. Let's go to sim. Should I just go for it? Okay, let's not do that. Let's terminate that. We have way too many logs going now. Because we are doing a lot of colliding. Logs are off in here. No logs here. That's fine, that's just test code. Let's get rid of it actually. That's cool. Let's check the logs here. Cert. Okay. And then in sim, let's check out our prints here. So print, get rid of print. Get rid of print. Okay, let's check it out. I haven't saved. Okay, that looks different. Definitely looks different. So I wonder what's happening on these ones up here. We're probably just going through it at some point, right? I mean, these are definitely looking more natural. They're not so boxy, right? Kind of looks like Florida a little bit, maybe like a sideways California. This makes sense. I think this is correct. This looks pretty good. I think there's different... That just depends on how far it bounces off the walls. This split right here, I feel like it's telling me that there's something wrong. Like there's, because see, this looks so natural. It's on the bottom right. Then you go to top left and it looks very wrong. This should be almost the same. So let's double check our bounce over here. Velocity is less than basically just put it on the top of it. I think it needs to be flipped. Let's try that. Whoa, that was dope, but I don't think that's right. That looks really cool. Definitely not correct. So why is it being so funky then? Does it look weird in other steps? It does. It looks weird in 2 also. What about in 10? Still looks weird in 10. In 20? Yes, it does. Yeah, that's just like a line that for some reason is acting funny. Well, let's put those logs back in. Let's try it again with 20. If I can get it figured out. So now we're looking at a y of, I'm going to flip the x into y. That's just, it's bothering me. It makes it honestly harder to look at. Okay, because the y is more constant. It doesn't change as much, even though it is a little backwards. So let's look at my zeros. Yeah, let's look at my zeros back at like 100 or 180, right? Here's my 0, and I'm looking right there. It's 40, 60, 80, 100, 120, 140, 160. Yeah, that really does spike up there. So my 160 line is very interesting. It looks like really anything on the 160 line. Yeah, let's try 180, 160. See what that looks like in our sim, or in our play. Play 180, I'm gonna need to get some 180, 160. Oh. So that's why it's doing that. Why would it do that? That's right on the corner, so that's like, that's crazy looking. Let's do it. Let's do another test. Test wall collision on corner. Okay, so it was 160, 180, and it should be less than 200, but it's not. Should fail. Yep, distance is 23. And so I want to know what the collisions were, because that was super weird. I don't know if I do like a double collision. That might be the problem. Horizontal, vertical, horizontal. That's what it does. So it's horizontal, vertical, horizontal. It's just the top, the left, and then the top again. So it goes like. Do we need to extend the like inbounds? Inbounds. Point. Plus whole wall thickness. I didn't do anything. So inbounds check, it's because it's definitely, it's colliding with it just fine. Like it knows that it's colliding properly, but it's just going straight through it instead of turning around. fine. Nothing weird about that. Let's print our frames. So issue interclines with a vertical and horizontal at the same time. Okay. I'll be right back. So what's the actual issue here? Collide with horizontal, right, so we get pushed down. Then we collide with vertical and another horizontal. Oh, that's not right. Hold on. Should only hit that vertical one once. It does. It should only hit the horizontal one once. It shouldn't re-collide the vertical. Is that even what it looks like it's doing? So it's saying it's colliding with the horizontal twice. That's really interesting. Because it's really not. It's truly not. I mean, it shouldn't be. It's definitely hitting the vertical one. But the vertical one doesn't look like it's doing anything. why did this not do anything? This didn't flip it, right? Okay. Well, let's move this down. That's when we actually should be doing it. Maybe that would help a little bit. Right. Now let's see what we got going on. So collider with horizontal wall. Change the X, what? You kidding me? Okay, vertical. Right, you change the X, correct. Horizontal, change the Y. Vertical, change the X. So, it hits the same wall back to back on the same frame. Which it should not do. Should have pushed it out far enough. Should I do whole wall thickness? Okay. I just wasn't pushing it out far enough, I guess. Let's see what happens now. Yeah, that's how it's supposed to go. Let's check out the sim. Okay, this is looking pretty proper. I do see the lines on the top. Imagine that's where we are phasing through because we're going too fast. But all the rest of this now looks correct. This is how it's supposed to look. Except for at the top. Let's see, what's our easiest duplicate of that? Is it 2? Let's go at it, man, we're on a roll. 2 does it. It's 5. 5 doesn't. Does 10? 10 does not. 10 looks pretty clean. So it's on the 5. And it looks like, yeah, if we go all the way back to the top. Come on. We got some that explode that should not. So here's our 0. So we're looking at like 0, 1, 0, 1, 2, 3, 4. How far down do you think that is? Well, one of these is massive. Like the zeros are 300. So we're looking at 300. We're going to hit like a 500. 500 plus, probably. Yeah, here we go. 10, 515. So 515. What? That should be way before, too. Let's do the top left one. 1085. Check out 1085. Five and 10. Test. I'm guessing this is wall phasing. Less than 200? Less than 300 for sure. And it'll fail. Yep. Probably no collisions, I'm guessing, is what's happening. Yep, it's just going straight through. Okay. So what can we do to stop this? Let's check out our main and play. Change it to 85 and 10. That goes straight through the corner. So it is going through both of them. Just perfectly through them. So that's not good, right? So that means the speed distance to wall is less than self-net radius. Okay. Breaking into quarter steps. Or at least breaking into something else. So I guess I don't need to know if it's like close enough to hit right now. I need to know if it's going to be close enough to hit on the line. So let's try that. Distance to wall is self dot pos. Let's do plus self dot val divided to. Well, self dot radius. So this checks it at its current step and at its half step. This was just 300. I think that fixes it. Yeah, it's just still moving crazy fast. That's an interesting little roll off. I guess that's how it comes out. Something like that. At current pause and at half step for collision. So one thing about that is that we are now doing twice as many calculations per frame. So, we don't love that. But it's fine. Let's see what that turns. Did that break the sim? If it's like real bad, you know. Oh, that might. Ooh. Get those out before we run. Okay. That's gonna burn up. All right, we are cooking. We are cooking. I do see a couple dots up here. Still, I think that is because we might have like just hit a perfect little notch. There's one down here too. Or maybe that might just be a little thing on my screen. But definitely the ones up here. Might have just hit like little perfect notches up there. Let's see what I can do with that. So I think those are probably because we don't think that it's in bounds. So let's think about this. So if it's horizontal, the x has to be greater than the left. Let's just add like a wall thickness to the left, right? That's wall thickness. And then let's add wall thickness to the right. Then here, thinking vertical has to be greater than. So again, let's add wall thickness. And then let's subtract wall thickness. No, subtract. And add. I always like, for some reason, I'm always thinking backwards, but it's always just normal. It's always normal. This should be fine. That's just adding more collisions if they don't go off the side. So let's see if that was that. Yeah, print it out. Okay. Those little dots are gone. So it looks like that was the case for those. Looking pretty clean. Yeah, I like how this looks now. I think this is kind of the final thing that we need to do with this. It's pretty exciting. At least I think. I mean, look at this. This looks great. Maybe still a little weird when we get close to certain walls or something, but this looks damn good. Now we can start having some fun. I'm gonna end this video because I think I've spent enough time on this for now. I might come back to this after I get some food, even just later tonight. But let's end it for now. So today, what did we do? We finished concurrency bugs. We finished collision bugs. Next time, I'm gonna make the map editor so that we can build some maps. And yeah, make some fun things happen. All right, thank you for joining, and I will see you in the next one.